Just a short video today to talk about the use of an ammeter and considering the burden voltage of that ammeter. Anytime you stick an ammeter in series with a circuit that you're testing, you're effectively adding a small series resistance in series with that circuit that you're testing, and the meter is essentially internally measuring the voltage across that resistor. That voltage across that resistor is called the burden voltage of the ammeter. Now, why do we care about this? Well, the voltage drop across this resistor means that your circuit under test is not going to be seeing the voltage you intended to apply to that, because there's some voltage lost across that resistor. Will that be a problem? Well, it depends on the circuit, and it depends on how much drop you're getting across that resistor. Also, if the circuit under test, if its load varies over time, meaning this voltage drop is going to change over time, that would then mean that the voltage being applied to the circuit will vary as a function of the load change, and that could be a problem as well. Now, of course, the value of that resistor that appears in series here is going to be a function of the particular meter that you're using, as well as the range that the meter is in. And that could present another problem. If your meter auto ranges, as you're maybe adjusting the circuit or something like that, and it changes ranges, it might actually change the value of that resistor at the same time, and in doing so could disrupt the circuit under test, or certainly change the voltage drop across that resistor. So it's really important to consider not only what meter you're using, but what range it's being used on, and how that burden of voltage will affect your circuit under test. So let's go take a look at two examples here of meters that I have and what the burden voltages are at different current ranges. Got a very simple test configuration here. I've got a power supply, actually a variable power supply that I've got set to a current limit of about 35 milliamps or so, just for this example. Just a 100 ohm resistor here to prevent any peak currents from getting too large. I've got the ammeter under test right here, so we're just going to measure that current, and I've got another DMM sitting across that meter so I can measure the burden voltage directly. So this Fluke 79 from about the late 90s or so is the first meter that we're using as an ammeter here, and I can see about a little over 35 milliamps of current going through that meter. Now the Fluke 87 here is actually measuring the DC voltage drop across the meter terminals here, and we can see I've got about 377 millivolts of voltage drop across this meter with just 35 milliamps of current flowing through it. So consider you're operating or working on a circuit that's powered from, say, a 3.3 volt supply. Okay, and if that circuit's drawing 35 milliamps and you stuck this meter in series with it to measure that, the circuit now is only going to see a little less than 3 volts. It's about a little more than 10% of the supply voltage is being dropped across the meter. Okay, and you might not have expected that. So that certainly could affect things. So this kind of implies that resistor is, somewhere in the neighborhood of 10.5 to 11 ohms of resistance that we're sticking in series with the supply. Certainly something to consider. Now, if we take a look at the specs for this meter, we can see that on the 4 milliamp and 40 milliamp ranges, and we're using the 40 milliamp range here, that it does specify that the burden voltage is 11 millivolts per milliamp. Well, that says it's 11 ohms is the series resistance. So it's right there in black and white. And again, might not have been something you considered. But look, if we actually change and use either the 4 amp or 10 amp range, that burden resistor, if you will, the series resistor drops from 11 ohms down to 0.03 volts per amp, or 0.03 ohms. So the burden voltage will be much, much lower. Let's take a look at that. So in order to do that, I'll just move my connection from the 40 milliamp connector down to the 10 amp connector. Now, of course, I'm not going to get as much resolution here because now this is on the 4 milliamp scale, but I still see the 35 milliamps here. And now look at the burden voltage. The burden voltage is just barely a millivolt. In fact, if we switch this to the millivolt scale, I can see that it's just barely a millivolt. So now that the problem that we were seeing where we were dropping 370 millivolts across the ammeter has now essentially gone away at the expense of resolution, and that's essentially what you're going to find. So in the case of this Fluke 79, there's really only two different series resistor values that we have to consider, the 11 ohm and the 30 milliohm resistor values. And again, of course, the trade-off is the resolution that you'll have in measuring current. So again, it's something that you've got to consider when you're measuring currents in your circuit to decide how much voltage drop am I willing to lose across the meter. So let's compare, let's kind of switch things around and look at how the Fluke 87 behaves. Okay, so looking at the Fluke 87, that's now measuring the current, and we're in the 40 milliamp range here, so I'm still seeing about that same 35 milliamps of current. And now the voltage across the Fluke 87 in the 40 milliamp range is just about 55, 56 millivolts. So the burden voltage of the Fluke 87 in a 40 milliamp range, like we were looking at with the other meter, is a lot less. And we can see that in the specifications as well. So here's the spec for this old Fluke 87 for DC current on the milliamp scale here. The 40 and 400 milliamp full scale readings, the burden voltage is just 1.8 millivolts per milliamp, or about 1.8 ohms of series resistance. Compare that to the 11 ohms that we saw on the Fluke 79. So for currents in this current range, say from up to about 400 milliamps or so, the Fluke 87 is actually a better meter to use. Now, if we go to the 4 amp and 10 amp range like we did on the 79, we'll see that the burden voltage is the same spec as we saw in the 79. So both those meters would give you the same result in terms of burden voltage at those higher current ranges. But at these lower current ranges, the Fluke 87 is a better meter to use. Now, something interesting to compare is that the Fluke 79 has got a 4 milliamp current range, okay, whereas the Fluke 87 only goes down to 40, so I don't get as much resolution. However, on the Fluke 87, if we turn the page here on the spec, we'll see that if we use the meter in the microamp region, there is a 4 milliamp range for that. So let's compare, and we can actually get a 1 microamp resolution with that. So that's actually pretty good. So if we're dealing with currents below 4 microamps or 4 milliamps, you might say that, hey, let's use the Fluke 87. But now take a look at the burden voltage here, 100 microvolts per microamp. That means I'm going to have 100 ohms in series with my circuit if I use this range. So that may be a problem, especially if you're at the upper end of that range. You might drop more voltage across that than you want. So if a 4 milliamp range is important to you, you might find that, hey, the Fluke 79 has got a much lower, but it's got almost 10 times lower burden voltage for a 4 milliamp range than the more expensive and better Fluke 87. So it's not always black and white in terms of which meter is going to be the best one to use to minimize the burden voltage and its effects. It really is going to depend on what current you're driving at and what ranges are going to be using on the meter. Alright, so I hope this video helped you understand a little bit more about burden voltage, at least cause you to think about it a little bit before you just blindly apply your meter to your circuit and not consider the consequences of what the burden voltage might do to you. Thanks again for watching. If you like what you see, please give me a nice thumbs up. Subscribe if you haven't done so already, and as always, comments are always welcome. Thank you.